So here are the two review questions. What are the three reasons we might have a hazard in our data path? And how do we go about addressing those three issues? Okay, so the three reasons are data hazards, control hazards, and structural hazards. Now, for data hazards, these occur when data is not available where we need it. So, for example, if we need it in the ALU, it may not be available, but it is available later in the pipeline, it just hasn't been written back to the register. This may also happen if the data is not available when we need it. So, for example, we need to read the memory first, and the memory may take until the end of the cycle before we get the data back. Control hazards are when we don't know what instruction is next when we need to fetch it. So remember, the branch is later on, and we need to finish the branch before we know what the next PC is. And structural hazards happen if the hardware is busy. So if we have something else that's using the hardware. So for example, if we need to do two different additions, maybe one for a branch address and one to consider if we need to do the branch, we need two ALUs for that. So how do we address these issues? Well, for data hazards, we forward the data. So we go find the data somewhere else in the pipeline and we forward it. Or we stall if the data is not ready. So remember, we have examples where we have to insert no-ops or bubbles into our pipeline to slow things down and wait for it to be ready. For control hazards, we calculate the branch as early as we can. We move the branch calculation logic earlier in the pipeline. Or we're also going to stall if we can't. So we have this branch delay slot. We can't do anything there. We have to wait before we get the result. And for structural hazards, well, if we need multiple things to use the hardware at the same time, we build more hardware. So we saw an example of that where we made the register file double pumped so they could do two things in the same cycle.